Hello, everyone. Welcome to this webinar. We are going to wait just a couple of minutes to allow everyone to
Good
join.
morning.
Good morning. Good morning, Tassos. And then we will get started. So in around 2 minutes. Thank you. Okay, I think we can start. Good morning, everyone. Can you see my slides?
Yes.
Are they visible?
Yes.
Okay, great. Um, Welcome to the second webinar of organized by the LEADS project. Today we will focus on GHG emissions avoidance calculations and experience from the industrial perspective. This webinar will last until 11:30. It will be recorded and the slides will be shared with all of you after the event. And the recording as well will be published on the LEADS social media, the LEADS LinkedIn, and the LEADS website. You can ask questions in the dedicated time after each of the sessions by raising your hand using the raise hand function. There will be also an open discussion at the very end of the webinar where you will be all able to engage directly with the speakers. Of course, one-to-one meetings with our expert can also be arranged separately. You can feel free to contact us through our website, LinkedIn, or emails to get more information. This is a breakthrough of the agenda. My name is Edoardo Paganelli, and I work for Aspire. Within the LEADS project, my organization is responsible for communication and dissemination. There will be the second session will be held by Athena Prevenu from Admiris, Environmental and Sustainability Manager. And the third session from Yorgos, pardon for my pronunciation, Daskalakis, Head of Technology Management at Motor Hellas, who will provide a real case study from an application to the Innovation Fund on CCUS. Just some introductory remarks on the LEADS project before deep diving on today's session focused once again on GHG emissions avoidance. The LEADS project, whose full name is Creating and Managing a Pipeline of Horizon 2020 Projects for the Innovation Fund on CCUS, is composed by a consortium led by P&O Innovation, which represents our Innovation Fund expert, Admiris, who is hosting today's session, who are indeed GHG emissions calculations expert. Then we have ourselves, Aspire, which whom we manage the dissemination and communication and the H2020 Horizon 2020 portfolio management. We then have IDE clusters, which connects CCUS applicants with EU clusters, specifically in the northern region. And then our three project owners, Novis, TNO, and Avant. In terms of project summary of LEADS, it belongs to Cluster 5, Horizon Cluster 5, support for the deployment of RNI results for climate mitigations and synergies with the ETS Innovation Fund. It is a coordination and support action, a CSA. It is indeed accompanied in its path by other four projects, which focus on different aspects of of renewables. We have hydrogen, low carbon technologies in energies intensive industries. Indeed, each of the 5 CSAs deals with a specific aspect of innovation. In terms of objectives of the LEADS project, the quintessential one can be indeed seen as the creation of a pipeline of Horizon 2020 and Horizon Europe projects to apply to the Innovation Fund. It is indeed in a way to assess and select the most suitable projects which are able to move further to deployment. Another very important objective is that of allowing CCUS project owners to overcome what we call residual bottlenecks, so as to allow them to prepare for an Innovation Fund investment decision and ultimately to apply to the Innovation Fund mechanism. Another very deeply interconnected objective is that of fostering synergies between Horizon 2020 or the Innovation Fund, as well as with other EU funding programs. We have, in this scope of action, we have created a number of tools which are publicly available for stakeholders to support them in various forms. The organization of such webinars, the first focus on feasibility studies. Today, we're focusing on GHG emission calculation, is in a way part of these program tools. Of course, the ultimate goal of the project is that of unlocking the full carbon reduction potential of Horizon 2020 research and innovation results. In order to achieve the objectives which are presented in the previous slide, LEADS has structured its project activities following what we call the innovation funnel approach. The process starts with an initial mapping and selection phase, where the most promising research projects with high potential are identified through a preliminary assessment. This phase is still ongoing, and organizations involved in CCUS projects, in CCUS activities in general, can be selected to become part of the LEADS pipeline. The projects that successfully pass this first selection phase officially enter the funnel, and they undergo a viability check and a gap analysis. The objective of this step is to assess the project's strength and weaknesses as well, and determine whether it is sufficiently mature to progress to the next stage. The most mature projects then move to the following phase, where they gain access to dedicated training and coaching delivered by LEADS experts, including P&O Innovation and Admiris. The purpose of this support is to help projects strengthen their feasibility and prepare a successful Innovation Fund application, which represents, in a way, the ultimate objective of the LEADS project. In addition, we also develop, as mentioned before, tools and services that are made publicly available to support research and industrial projects in improving their readiness and understanding of the Innovation Fund requirements, which sometimes can be hard to grasp at first. This is why in the next slides we will present some examples of these tools that are already available. For example, we have the Innovation Fund guidelines, which are focused on different aspects of the Innovation Fund, covering eligibility, award criteria, business plan development, feasibility studies, GHG emissions avoidance, and other practical tips and tricks, which are available on the LEADS website, which you can access just scanning this QR code. In addition, we have also developed in the another tool which is called the Innovation Fund Self-Check Questionnaire, which is the way through which you can directly connect with the LEADS expert by compiling a quick, indeed as the name suggests, self-check questionnaire, answering a couple of questions. This will allow you to be recontacted by our LEADS expert. Before giving the floor to Athena, I just wanted to mention the next step in the LEADS project. We have the third webinar coming up, which will be focused on the business plan and the financial modeling in May the next month. The date is still to be confirmed, but we will publish updates very soon. And in coordination with the other projects belonging to the CSAs and with CINEA, we are organizing in Brussels a public conference on the 12th of May, allowing you to really connect with policymakers, with project owners engaged in the Innovation Fund. Here is just a couple of links. You can indeed have the link to our website, the Leeds website, and also we are very much active on the LinkedIn page, which you can follow to be up to date with the future updates of the project. I'm gonna stop sharing. Yeah. The next speaker will be indeed Athena Prevenu, who will lead us through the key points for CCUS projects in the Innovation Fund methodology, specifically for GHG emissions avoidance calculation. Thank you so much, Athena. The floor is yours.
Thank you, Eduardo. Hello, everyone. Good morning. The content of my presentation starts with the scope of the GHG emissions avoidance calculations, the categories and sectors, some important definitions used in the methodology, the minimum monitoring period and the minimum avoidance emissions that we need to have, a quick overview of the methodology, specific cases for the reference scenario, and specific cases on CCUS projects, and finally the summary. Starting with the scope of the GHG emissions avoidance calculations, we need it in order to monitor the GHG emissions that we have during the operation of the plant. And we need it also for the scoring, and it is a KPI for the Innovation Fund project. In the case that the maximum grant can be given only in the case that at least 70% of the total amount of the GHG emissions declared are indeed avoided. While if less than that is avoided, then the grant will reduce proportionally, while in the case that we fail to have any GHG emissions avoidance, the grant will be recovered. Moving on to the categories, we have the listed categories that you can see on your left-hand side. The CCUS project fall into the energy-intensive industry categories. However, we can have also a hybrid project that combines more than one categories. Regarding the sector of the energy-intensive industries, when we have a CCU project, needs to fall in the sector that you see on the right-hand side, while when we only do a project related to the transport, then we have CO2 transport and or storage, we have CO2 transport and CO2 storage accordingly. Moving on to the important definitions, each project could have several products, but needs to have one principal product that we need to define based on the revenues, the main name and innovation of the project. With this principal product, we aim to substitute an existing product which has at least equivalent function or even better function than a product that produced by the state of the art. The state of the art and the processes including to produce the reference product are called the reference scenario. And in our case, we have the project scenario that includes all the processes for the production of our products and mainly the production of the principal product. The system boundaries of the implemented project includes all the processes that are owned by the parties that are directly involved in the project. However, when we want to estimate the GHG emissions avoidance calculations, we need to expand the system boundaries in order to include all the downstream processes that are required to produce the principal product that we are aiming for the CCU product in our case. And we need to include upstream emissions only in the case that these processes are under the control of the applicant and they're in the scope of the project. And in the last line, you can see the emissions that need to be included in the calculations. Moving on, it's important that it's important to calculate the absolute emissions, which are the GHG emissions from the reference scenario minus the emissions from the project scenarios minus the emissions from the credit from the CCU, from the storage and or utilization. Regarding the credits, is the summary of the carbon that is stored, the carbon that is used minus the carbon that is emitted during capture, injection, and transportation of the CO2. While we can have net carbon removals when the project, the emissions from the project scenarios minus the emissions from the credits are below to zero. We cannot claim a CCU, we cannot claim a credit, a carbon capture credit, in the case that we have a project that belongs to the manufacturer of components. When we established CO2 from current markets, for example, from CO2 that needs that will feed the production of beverages or the growth of greenhouse plants, and when this CO2 is produced intentionally, or in the case that is a byproduct of hydrocarbon extraction. The minimum period for the monitoring of the CO2 for the pilot at small scale is 3 years, while for the rest of the project is 5 years. We need to fulfill we need to fulfill the 75% of the relative GHG emissions avoidance for the pilots, while for the rest of the project this should be at least 50%. And typically, the overall monitoring period is 10 years after the project is into operation. Regarding the methodology, we need to start by defining the project, which are our product that this project produces, to pick our principal product, to pick its use, if it has multiple uses, and we need to have also supporting documents to verify that this product will be used as it's supposed to be used. Then we frame the system boundaries for our calculations. We go to the methodology, we identify the sector and the section of the methodologies, and then we move on to the formation of the reference case, where we pick the reference product and the system boundaries and the system boundaries of the reference scenarios and all the processes that belong to the system boundaries of this scenario. Then we gather all the operational data and our assumptions that we need to include in the Innovation Fund Excel workbook. For the GHG absolute emissions, for the reference case, we need to include the GHG emissions from the inputs, the process that we have in our boundaries, and the end of life of the reference product. In the case for the project, we again need to include the emissions from the inputs, the processes, but also if we have some CO2 savings from change in the use of this product, and also end of life. Here I have a note that in case that we can prove that the carbon in the product is stored for more than 50 years in the product after this product is disposed, we can claim that the end-of-life emissions are only 50% of the stoichiometric carbon that it's incorporated in the final product. And unlike the cases of some LCA studies, for example, we cannot include emissions from the equipment. We cannot include the emissions from the extraction of the fossil fuels, from the transportation of inputs, intermediate products, waste treatment, and the distribution of the final products, also the decommissioning of the plant and equipment. Here I have the list of the cases that we need to go through one by one in order to pick our reference scenario. We have 8 very specific ones. However, when we don't fall under any of this, then we need to form our own reference scenario, that this needs to be in line with the data hierarchy that it is in the annex of the methodology. And regarding the specific cases for the CCUS project, the first case is that we own a plant and then we have the carbon capture and storaging. Then in this case, our principal product is the main product of the plant, and we can claim the credits from the capturing and the storage. In the case that we own, for example, a steel plant, and then we have the carbon capture owned by the project owners and the utilization by the project owners, and we are producing the CCU product, then both of them are products of our project, and then we need to pick which is going to be our principal product based on the main innovation of the project, the revenues, and the main aim of the project. In the case that we own only the production of the CCU plant, so we take as input captured CO2 owned by a third party, then we don't need to include in our calculations the emissions from the plant owned by the third party. However, when we own the plant and we own the capturing, but we don't own the production of the CCU plant, in order to claim the credit, then we need to include in our system boundaries the production of the CCU product, even in the case that it is owned by a third party. Here I have a list in the case that we have a 0 rating because of the carbon that it is from biogenic, and in the case that this is not the case. When we combust biomass, then we have a 0 rating. However, when we capture the CO2 from a biomass, then and we use it into a CCU product, then no matter of the carbon, if the carbon is biogenic or not, then we don't take it into account. We don't take the 0 rating. The same is in the case of storage. The same is in the case of credits. And the same it is in the case that we have a renewable fuel of non-biological origin and low carbon fuels. So in the case that we have a CCU product, that it is because of the carbon of this of the biomass and low carbon fuel and the renewable fuel, then it loses its 0 rate credit. To sum up, we need to start by defining our project, defining the products, the principal product, and the processes that belong into our system boundaries for the calculations. Then we need to have supporting documents that will justify the use of the CO2 that is captured and or it's stored. Then we go to the specific sector and the specific section of the methodology. After doing that, we need to form the reference product and the reference scenario with all the system, with all the processes included in the system boundaries based on the 9 cases that we listed before and are also in the methodology. We need to report all our assumptions and operational data in the Excel workbook that is provided by the Innovation Fund. And we need to keep in mind that we have 12 points because of the GHG emissions avoidance. And we have one also bonus point from the net carbon removal in case our project can achieve that. This is it from my side. And before we move on, if you have some questions.
Indeed, if you have any questions, you can raise your hand. Okay, yeah, we have one question. Please, Theophilus, go ahead.
Yes, please, I want you to elaborate on the 12 points of the GHG emission.
I haven't there are 5 big of the absolute and 5 from the relative GHG emissions. So from these ones, but for the rest two, I don't remember them by heart. Sorry for that. I can look them up. So absolute for the relatives and of the credits, and 1 bonus point if we have net carbon removals. But it's very clear in the methodology the amount of the point for that.
All right.
Any other question on the floor? If not, we can move forward with the second speaker. Yorgos Daskalakis, Head of Technology Management Strategy Division at Motor Oil Hellas, who will guide us through some tips on the GHG emissions avoidance calculations, specifically tailored for a successful innovation fund application with the example of the IRIS CCUS project. Thank you so much, Yorgos. The floor is yours. Thank you.
Thank you, Eduardo. Good morning, ladies and gentlemen. Hope you're having a good morning, a good start. My name is George Daskalakis. I'm heading the technology management of the strategy division of Motor Oil. And one of my things that I'm doing is that for the last almost 5 years, I'm managing the IRIS project from its very conceptual design to the application of for the innovation fund twice, and currently the engineering. If we can move on to the next slide. Can I do it myself or? Oh, okay. Right.
Yeah,
So,
you can say them.
Yeah, all right. Right. IRIS is an innovative carbon capture project that is it's currently under development at the refinery, Motor Oil's refinery in Corinth. We applied, as I told you, twice. The second time, it was 2023, we managed to be selected for innovation grant awardment, and then we actually signed the innovation grant agreement for 127 million euros. Our current direct CO2 abatement is 520,000 tons of CO2, and we plan to have it on operation by 2031 Q2. I forgot to tell you that our carbon capture project is centered on our steam methane reformer, currently the main hydrogen producing unit of the refinery. And apart from the carbon capture equipment and unit, it comprises also the compression, the liquefaction, plus a methanol unit for the production of renewable methanol, with the aid of with the supply of electrolytic hydrogen from an electrolyzer, a 50 megawatt electrolyzer currently under construction. Can we move, please? Right. Okay, I'm trying to take you through the perimeter of our project. Actually, at the lower end, at the low left side, you can see our SMR. Our SMR is producing approximately 500 to 600,000 tons of CO2 per annum, meaning that it's about 9.5 tons of CO2 per ton of hydrogen. Albeit it's a small quantity, it still comprises 25% of the refinery, of the emissions of the refinery. And this is quite a difference between a refinery which has approximately 15, 16 emitting points versus a cement point where you have just one emitting point, or at maximum two. So by capturing one of these, the biggest and the most condensed dense gas stream, we managed to have a quite big contribution to the reduction of the CO2 emissions of our refinery, approximately 25%. So we started from here. So the main product is hydrogen, but also it produces high pressure steam. It's one of the main, as a byproduct, it's one of the main high pressure steam of the refinery. Both hydrogen and steam are vital for the operation. And that's why we had to be very careful on how we'll intervene. And in order not to touch the balances of the refinery at all or interact with them, we decided to go with a post-combustion capture. But also because we selected this because we needed to achieve a threshold for the hydrogen to be below 3 tons per CO2, which is the taxonomy threshold. So it's an amine solvent. It's an amine carbon capture unit, quite advanced, but also quite old as an idea for the refiners. And then we capture approximately 95% or even more. We have the conditioning and the compression of the refinery where we get of the gas stream, of the CO2 gas stream. Part of it, the majority of this quantity is liquefied and temporarily stored. And then approximately 480,000 tons of CO2, which are waiting to be shipped. Part of the CO2 is going to a methanol unit that will be receiving green hydrogen from a 30 megawatt electrolyzer. This was the old setup. Now it's up to 50 right now as it is constructed, which is beyond the perimeter of the electrolyzer, and then beyond the perimeter of Iris. And then we will be producing 25,000 tons methanol. Currently under investigation whether we'll move up to 40, which will be directed to marine fuels, chemicals, or nothing of this works to our existing MTB units. The blue hydrogen will be directed in the refinery, as it always does, together with an option to blend it at quite low concentrations with the existing natural gas. The plant is currently receiving natural gas, of course, as the main feedstock for the SMR. At the same time, there are plans to introduce biomethane. The electricity will be provided via PPA with RES power. And also we managed to cut off completely the receipt of steam, low pressure steam that is used in massive quantities at this capture unit, approximately 70 tons per hour. And we replace the steam and the carbon footprint that this steam brings with a 17 megawatt heat pump. Can you please move? Can we please move? Right. Okay. When I received the invitation was mostly directed to the lessons learned in general. So I will spend some time to this. You can see that it's quite a long story. We started at approximately end 2020. We went through different stages. We went through pre-feasibility studies, irrespective of our application. There came the idea for applying. We did our first application with our data, our engineering, our internal CapEx estimates, and so on. We failed. Why we failed? We failed because we were very introvert. We were not actually serving the purpose of the Innovation Fund to create an ecosystem, to create something that can be replicable, to create something that will create a new market. And it was just a refinery unit, yet another refinery unit. What happened in the second application attempt, it was that at this time we had next to us the project EFIRA and Triiris that were Horizon project, currently under development in the refinery, that were centered around the hydrogen economy, the hydrogen market, and also we had the potential for the electrolyzer. At the same time, and I need to tell you that it's quite important to follow the regulation, it came up that we can use fossil CO2 for the production of maritime methanol or RFMBOs in general till 2041, and that opened an opportunity window to introduce the methanol idea, and from there on start another branch of activities, and let's say we started becoming more extrovert. We managed to get to sign the agreement, as I told you previously. Then we went through quite a long time to select contractors for the pre-FEED study. But it took us a lot of time to complete the pre-FEED study because we have to go back and forth. And we need to say that despite the fact that carbon capture may sound quite, how to say, usual, it's not at all. And in this same respect, the contractors are learning. Okay, so we had to go back and forth, and then we had to face the pre-FEED study finally concluded, and then we have to go through the most difficult part that we are fighting for establishment of the regulatory framework here in Greece, which is quite arduous and tiring process. And at the same time, we are working with our engineering. So this is the case. As you can see, that there are many things to consider. Probably the application is the easier part. Because when it comes real, you have to consider everything that you have to do in an operating plant, and also to take into account the real financing and so on. If I wanted to say something, I would say that the first time failure, it's not a case. It's nothing. If you can do it, do it. Not try to be 100% ready, because you will never be. We used consultants 2 times. They need to be experienced in manipulating, in using the systems of the Innovation Fund, in using the terminology, in being able to contact and connect with the help desks and so on. The innovation for our operating systems, for our operating plants, which are large-scale innovation funds does not mean that you will take a TRL 5, 6 technology, because you will never do for such for an operating refinery. But so the technologies are not themselves very innovative, and especially for refinery, we are very conservative. We are not introducing things without knowing them or without. Excuse me. Sorry, I have a phone call. So for our case, for a large-scale innovation fund, the business model is needs to be innovative. The scale and the synergy needs to be innovative. The first mover is innovative. Brownfield projects have to operate existing current rules, and we cannot overcome them by no chance. The GHG avoidance, we will come to this a bit later, just the next slide. It's the indirect and indirect via fuel switch, meaning the direct for us is the capturing directly from the steam methane reformer, and the indirect part is what are you replacing by introducing maritime methanol. You're replacing MGO, MDO, marine diesel fuel, let's say. And then from this thing, you get the difference between the two footprints is the thing that you gain, and you introduce it in your avoidance calculations. Similarly, with the hydrogen that probably be injected in the network, you displace natural gas. The project maturity is a criterion that's very, let's say, important. So for existing plants with existing operating rules and so on, use them and make them, and also use everything that you have in terms of commercial networks and banking involvement and so on. All these things needs to be there when you are applying. The scalability relates to the new value chains, the replicability of the project, how much extrovert you are, the synergies, and finally the financial effectiveness, meaning the amount of money that you ask divided by the amount of CO2 that you capture. It's not the whole CapEx, it's not the whole relevant cost, it's up to 60%. So some applicants prefer to go with a smaller percentage, below 60% of their relevant cost, in order to be more attractive, because the effectiveness is for the SINEA. It's not about your effectiveness, right? So it's the outflow that will happen for the SINEA side. This is the effectiveness. And we need to say that we need at least to achieve 50% reduction, and also the cost to be maximum 200 euros per ton of CO2. These are the main things that are assessed. Can you please give me 1 second? Excuse me for this, but I have something going on. Excuse me.
While waiting, just to give you an info about this refinery, it is one of the most is on the top 3 complex refineries in Europe. It's very complex. And this,
sorry.
Yeah, okay. Yes, Mr. Daskalakis. I was just informing the audience that your refinery is on the top 3 refineries in Europe in complexity. Yes. And this gives you the unique potential to use different feedstocks. Okay, it's not very relevant to this, but indirectly it is. Anyway.
Yeah, the thing is that we are operating in an existing facility, And this has all this complexity. You have, and most importantly, we are operating in a very congested refinery. No place to move around. So
Yeah.
this is my up to selection of the things that we've saw during our selection, during our application process. Of course, I know that the rules change with time. When we did our first application, we had to have audited business plans and GHG calculations. With the second application, we had to be only audited, only the GHG calculation had to be audited. I don't know what is the current status, but and these things need to be followed up closely, and that's why I told you before that the consultant needs to be very knowledgeable of the processes, of the contacts, and of the way to approach the SINEA and get the information in a timely manner during your application process. Okay. Now, can we move, please? Right. It doesn't show up very well, this this slide, but in any case, the purpose of this bar chart that you see is the other criteria, let's say the innovation, the technical maturity, the financial maturity, and so on. And finally, it's the GHG avoidance, the one in purple, and it's referred to the percentage of the project that fail because of this of each one of these criteria. Of course, the combination usually happens. It's not just the one. But at least these data are from SINEA's presentation that I happened to attend almost 1 month ago in Greece. And in any case, if we concentrate on the GHG calculation, which it appears to be only 5% as a reason to fail, 40% are the wrong assumptions. 40% relates to data not provided or not backed with supporting evidence. And we will go in the next slide to our calculations and how we see them, and I will explain in more detail what does it mean. Of course, as Athena said, the errors in the definition of the reference scenario. Probably this is the most complex part of trying to define what are you aiming for. A reference scenario, reference project, and so on, product, because each one has some, at least when we applied, I don't know exactly how these things work now, but they have some things that maybe appear to be more favorable for, and you want to avoid some extra miles, and you prefer one scenario over the other, and finally you find yourself at quite late in the process. This is not the scenario you are looking for. Anyway, again, the boundaries, the system boundaries, and what you take into account, both in your scenario, reference and the actual, and of course, the wrong application of the GHG methodology provisions. If we move to the next slide, I will come to take you through the focus mostly on the GHG calculation. First of all, you have to work with either scenario, whatever kind of calculation you will get through. You go. It's a very scary. Even now, the GHG calculation workbook, when I have to go back and do some checks and things, so on, just to remember what's happening, it really takes me time to remember which of the tabs I need to visit and find the data, and then make sure that it's a massive workbook with a lot of data embedded, all these assumptions that are coming with it. And really, it's a difficult tool, and it really needs a lot of cautiousness, high degree of cautiousness when you are submitted. That's why you saw that there are many cases with a lost or many errors in the submission. Right. Of course, we have to discuss you need to be very careful with the definition of the perimeter of both the unabated reference scenario and the abated project scenario. In our case, you saw that one thing that I didn't say. Right. You saw that the reference scenario is the SMR, and then which produce only hydrogen. The project scenario contains the capture, the liquefaction, the production of liquefied CO2, which actually goes to the storage site, but also a new product that did not exist previously, the introduction of methanol. So all the things needs a lot of thinking of how you will insert them. You will use them in the calculation workbook. Then you have direct fuel consumption and indirect, that's coming with the steam, as I previously showed you. And also with the chemicals that you may use, the cooling waters that you may use, all these things have GHG footprint. And in most cases, you need to visit the assumptions tab, where there are many predefined footprints for this kind of calculations. And the thing is that you need to understand, and we will just discuss a bit later, that the GHG calculator, it's a tool for SINEA to bring all the projects on a level field. It's not a regulatory tool. It's not an assessment of your footprint or your greeniness as a product. It's a tool that all the projects are coming on the same level, and they are just, again, the same criteria, and at the end of the day, you get a GHG abatement. This is it took us some time to understand it because we started using it for other purposes and we were on the wrong side or the wrong directions. So, and of course, you can use project-specific measures if they are certified, right? So the abated iris, I gave you a description. You saw how it is. Now, the abated iris project extends in terms of, apart from the product, extends also to the storage site, meaning that the full abatement of this project includes also the product, the CO2 that comes from the vessel, and also the CO2, direct and indirect, that comes from the storage site, from the operation of Prinos or Ravenna or whoever will store it. And these are data that need to be obtained from the operators, and hopefully they're correct. Especially when it comes to sites that are currently under development. Again, we use the default values. Of course, a very important fact is that you need to include the monitoring process and the monitoring mechanism that you have. If you are ATS facility, let's say a refinery, which actually is under the ATS monitoring system, you have a monitoring plan, you have a reporting procedures, so you can refer to these procedures and the existing mechanisms that are already there in place to deal with the ATS project, with the ATS obligations. for your project. So you are at least you show that it's readily available. These mechanisms are already there. And of course, for our project, we have to take into account the indirect emissions, which actually, again, they are combined. The emissions are for the products are combined with default values for the products for the fuels that we are replacing. Okay, now if we move to the next box, the yellow box. What we have seen, this is the process, this is our cases. As I told you, at least in order for a project to be selected, it needs to achieve at least 50% over the existing scenario. The cost needs to be less than 200 tons per CO2, and this is quite a value because it covers quite a spectrum of technologies. The GHG abatement calculation, I think, or it needs to be audited. I'm not really sure. Athena probably knows if you need to submit the third-party GHG verification of the spreadsheet. One thing that is very important, you need to the figures that you have in your GHG XLS workbook needs to be reflected in the financial model submitted, meaning the flows, the mass balances, these things needs to be, and also the gains that we expect to get from applying, from not having to buy extra EUAs, because this is your main revenue for a CCUS project. The things that you don't need to buy. The abatement performance is a contractual agreement, it's contractual term in the grant agreement, and will be monitored during the operation of the project. As Athena said, you need to achieve 75% of what you have promised with your GHG calculation. If you move now, what happens during the operation mode? When you get the money, you need to at least you sign the agreement. You need to at least leave out 10 to 15% of your grant allocated to you, awarded to you, to be reimbursed during the operation years, right? So you leave, let's say, 10 million euros that needs to be taken in the next 10 years, which is the one. Athena, I don't know. We used to have 10 years on a monitored time, and then this came down to 5.
This is the minimum. In total should be 10 years. Yes.
Okay, right. So so you expect to, let's say, to get for the 5 years to 2 millions if you will be getting, if you achieve the at least 75. If you achieve between 60 and 75, then this amount is proportionally reduced. Okay. Now, if you go below 60, then the discussion starts where you have to reimburse money, capital from the main portion, from the 82% of the work that you have received till operation. The steam consumption is a major source of GHG, which penalizes the performance. Explore alternatives. And actually, when we introduced Iris, there was no heat pump early in the process. But during the engineering, we saw that we were spending a lot of money, even indirectly, because we had available steam at the refinery. But even though the amount of money was because the steam is calculated on the basis of the marginal fuel that you use to produce it, and if we were spending this amount of steam in Iris, then we would have to burn natural gas, which was very expensive. So we introduced Iris heat pump. One caution, by the time you introduce new things, you are not, the amount of money that you're going to get do not change, right? The grant remains the same. No matter what you do, no matter what improvement that you do with the project, the amount of money does not change. So, but if you want to be real, you have to save money for during the operation one way or the other. And of course, you save the GHG calculation, the GHG attached to these things. As I told you, the GHG calculation is to bring the projects to an even level. It's not a regulatory tool. It does not correspond to any of the documents that are currently around RED 3, Fuel EU, Refuel EU, RFMBOs, and so on. If you want to do this kind of things, you need to do a very separate estimation, a separate study, and it's good to have it attached on your project by the time you start engineering, because things are changing and you need to have these calculations to be repeated every time something is changed during your design. But these are for the operation part, for the engineering part, actually. Actually, we have a study ongoing. We have a tool that we developed, and we follow regulatory changes. And these are giving us the ability to plan for where to source, let's say, electricity, what is the footprint, and whether we can send it to maritime or where we can send it to other industry and so on. Products utilizing CO2, as it is captured now, CO2, fossil CO2, penalizes actually the abatement performance, because the CO2 that is used for products, let's say methanol, are not permanently stored. And in that respect, you need to pay for the amount of CO2 used for the, let's say, 36,000 tons that you've seen in your previous slide. And the EUAs needs to be surrendered. And when you have done this, then your product that you will be producing with the green hydrogen and capture CO2 can get the credentials of RFMBO 2041. And finally, if we move to the next one. Okay, this is a wrap-up slide. The project timelines when you're designing needs to be very carefully considered, especially we are very much dependent on exogenous factors. As a general comment, the CCS projects are chain projects. You rely on upstream actors and downstream actors. And these need to coordinate their actions, and which is not always the case. Now, the grant agreement GHG performance cannot change. By the time there are contractual terms, you sign an award for an agreement for 120,000 million euros. This cannot change no matter what improvements you make, no matter what. You cannot change the performance that you have promised, and that's why you are attached to it and you are monitored. Of course, this needs to be taken into account that by the time you start and you apply and the time that you are currently doing the engineering, the inflation is skyrocketed, especially with these current conditions. You need to be very careful when you are trying to be attractive and asking for less than you think, because really most of the cases you go on the higher side during execution, during engineering. So you take a lot of hard goods then in loans and equity that you need to inject for the project in order to make it fly. Of course, I told you about financial close and FID. Yes, in order to have the financial close and get the first one in your hand, you need to have FID and apart from everything else, which is not always the case, especially during this time, these times that we are in. AWAS, the money of ATS, the amount of the value of the ATS. The ATS is as I told you, the source of revenues for this kind of project. And I don't think we are feeling very comfortable during these days because we are discussing about easing the ATS. Meaning easing the ATS means that there will be a good proportion of projects with a question mark on them. And I stop here. And of course, the regulatory framework that are in force in its project's host country needs to be very well studied. If in the development stage try to consult, try to participate in the consultation, because there are many, interests that are fighting for the same market. That's all from my side.
Thank you so much, Yorgos.
Thank you,
It was
Yorgos.
very, very insightful. If anyone from the audience has some questions, we still have some time for follow-up and for the open discussion. Yes, Tassos, please go
Yes.
ahead.
First of all, thank you very much, Mr. Daskalakis. It was, I think, the best presentation we have made in this series of webinars. Just to cut the long story short, there is an opinion which is widely circulating in the let's say lobbies of European Commission is that for innovation fund, despite being innovation fund, by far the most important part is the GHG emission savings. And then it comes the innovation, and then it comes the money making and the profitability and so on. Do you agree based on all the things that you have experienced so far, or it's just an urban legend and we need to pay attention?
First of all, when we're discussing about, you cannot go very Okay, first of all, we're discussing about saving money for the environment. The other thing is that introduce technologies at a certain level. You can remember that there were two kinds of innovation funds: the small scale and the large scale. The small scale, where you have pilot plants, it's another story. Probably you can go with the lower TRL technologies. And you can test them. But when you are in an operating plant, by no means you can go with a non-tested TRL 6.7, even 9, without any references. First of all, the insurance companies will not allow it. It will become very suspicious. And of course, you have the people operating then. But the thing is that, as I told you, we did not bring just another amine unit. You know how many amine units we operate in the refinery? 3. But not at this scale, and not for CO2. Okay? By the end of the day, we need to improvise in order to produce a product which will be liquefied CO2, that it's the requested specifications from the storage sites is of the pharmaceutical grade. So we need to introduce this one. We need to introduce innovative ways to have the stage is very large. We're introducing the methanol unit. The methanol unit probably is the most innovative because it's the with the least number of. We're trying very hard to find live sensors with actual reference sites that we could go and see them operating. Okay. We brought in an electrolyzer and we use the hydrogen of this electrolyzer. It's another thing. And yes, you go for this kind of innovation on the side. And of course, with the aim to achieve at least 50% carbon reduction and a certain amount, financial efficiency in terms of euros per ton CO2 capture. Avoided.
Yes. Okay, thank you.
If any other question, comment, feedback? Okay, I think you have been very clear, Yorgos, and yourself, Athena, as well. If there are no further questions, we can close the webinar. Thank you once again for joining. As promised at the very beginning, we will send you by email the full set of slides, and we will also post the recording and the slide set on the Leeds website and on the Leeds YouTube channel. So yes, this will be done in the coming hours and days. So see you soon at the next and last webinar, which will be focused on the business plan. Thank you so much once again to the speakers.
Thank you very
and to all
much,
of you
Mr.
for joining.
Daskalakis. Thank you,
Thank
Eduardo.
you. Thank you so much. Goodbye.
Bye-bye.
Goodbye.
Bye.
Thank you. Bye bye.